Welcome to the second video in the wave function collapser video documentation. This one we're going to be taking a look at the sockets example. We'll open that scene and run the game, and what we get is this little network of roads laid out randomly. So let's take a look at how this scene is created. There's the demo game object, and under it a bunch of different meshes. In this example, each road network tile is actually a slot in the wave function collapser terminology, and it can be moved around. At the top level, at the demo game object, there's a component called the road demo behavior, which is code we'll look at in the next video. You can see that it has a wave function collapse config, so let's take a look at that next. We have a set of modules as described in the previous video, but the way that the constraints are generated is different. These constraints use a socket approach. Let's take the straight horizontal piece. It has a 1 value for the left and right socket. That means that this module can only exist to the left or to the right of another module that has a 1 in those sockets. So for example, because this has a 1 in the right-based socket, it could not live to the left of the vertical piece because that is not a 1, that's a 0. On the other hand, this horizontal piece could live to the left of this turn piece module's 1. Because of the socket value. In this type of configuration, you can set these socket values to whatever you want as long as they're integers. You can create your own example of a socket configuration by, in your assets, right-clicking, creating a brooding WFC sprite socket config. There are a few other properties that I want to take a moment to look at on this configuration. The first one is the use seed checkmark. When the wave function collapses, it'll select randomly between available modules at each slot. That randomness can be reproducible between runs if you use a constant seed. Otherwise, if the use seed checkbox is unchecked, every time the game runs, the function will collapse differently. So for example, if I run this now with a seed of 0, take note of this particular patterns that we're getting, and if I run it again, I should get the exact same thing. But if I change my seed to 1 and run it, I will now get a different pattern. But if I change it back to 0, I'll get the original pattern. Great. The other property I want to take a look at on this config is the weight on each module. The weight will control how likely the module is to be randomly selected during the collapse. So right now, all weights are at 1, which means all modules are equally likely to be selected. But for example, if I take the horizontal title and set its weight to something high, like 50, and now I run it, we'll see that the horizontal tile is preferred in the random selection, and we get a very different output pattern. I'll change it back down to something a little bit more reasonable, like 4, and I'll also make the vertical tile have a weight of 4. This will prefer to create generation spaces that have much more straight segments than they do turn segments. We can see that that's true here. Okay, that's all for this video. Thanks for watching.